Hello dear students, all of you welcome to Vidyayana classes. Today we will discuss some important expected board questions on determinant. Find the value of the determinant. Answer: let del be the determinant cos square alpha, cos square beta, cos square gamma, sin square alpha plus 1, sin square beta plus 1, sin square gamma plus 1. 1, 1, 1. Applying C1 replaced by C1 plus C2 and C3 replaced by 1 by 2 C3. So the determinant will be sin square plus cos square plus 1, that is equal to 2. Sin square beta plus cos square beta plus 1, that is equal to 2. Sin square gamma plus cos square gamma plus 1, that is equal to 2. Sin square alpha plus 1, sin square beta plus 1, sin square gamma plus 1. C3 is replaced by 1 by 2 C3. So half of 2, 2, 2, which is same as half into 0, that is equal to 0. Since C1 is equal to C3, the value of the determinant vanishes if two columns are identical. Clear? So the answer is 0. Next question. What is the value of the determinant where iota square is equal to minus 1? Answer: let del be the determinant iota to the power 103, iota to the power 56, iota to the power 21, 3, 5, 7, iota to the power 101, iota to the power 54, iota to the power 23. Iota to the power 103, which is equal to iota square 51 into iota, which is equal to minus 1 into iota, which is equal to minus of iota. Iota to the power 56, which is equal to iota square 28, which is equal to minus 1 to the power 28 is equal to 1. Iota to the power 21, which is same as iota square to the power 10 into iota, which is equal to 1 into iota is equal to iota. Iota to the power 101, iota square to the power 50 into iota, which is equal to 1 into iota, that is equal to iota. Iota to the power 54, iota square to the power 27, that is equal to minus 1 to the power 27 is equal to minus 1. iota to the power 23, which is equal to iota square to the power 11 into iota, which is equal to minus 1 into iota, which is equal to minus iota. So the determinant del will be, so del is equal to minus iota 1 iota 3 5 7 iota minus 1 minus iota, which is equal to negative of, taking minus 1 from column 1, that is the iota minus 1 minus iota 3 5 7 iota minus 1 minus iota, which is equal to minus 1 into 0 is equal to 0. Since C1 is equal to C3. Clear? The value of the determinant vanishes since column 1 is equal to column 3. Therefore, del is equal to 0. Clear? So that for all real values of lambda, the system equations lambda plus 3 whole into x plus lambda y is equal to 0, x plus 2 lambda plus 5 whole into y is equal to 0 has a unique solution. Prove. To prove the statement, it is sufficient to show del not equal to 0 for all lambda belongs to real set, where del is the determinant of lambda plus 3 lambda 1 2 lambda plus 5. Clear? Which is the same as 2 lambda square plus 5 lambda plus 6 lambda plus 15 minus lambda, which is same as 2 lambda square 11 minus 1, that is 10 lambda plus 15, which is same as 2 into lambda square plus 5 lambda plus 15 by 2, which is equal to 2 into lambda square plus 2 into lambda into 5 by 2, which is equal to 5 lambda, plus square of 5 by 2 plus 15 by 2 minus 25 by 4. This and this cancel. 2 cancel. Which is same as this. Which is equal to 2 into lambda plus 5 by 2 whole square plus adding this 4 30 minus 25 that is equal to 5 which is equal to 2 lambda plus 5 by 2 whole square plus 5 by 2. At lambda is equal to minus 5 by 2, the result is 5 by 2. So the minimum value of this is 5 by 2. Otherwise it is greater than 5 by 2. So greater than equal to 5 by 2 for all lambda belongs to capital R. That is real set. Clear? Which implies del greater than equal to 5 by 2 for all lambda belongs to real set. That is the minimum value for del is 5 by 2. So del not equal to 0. Therefore the statement is proved. That true. Clear? Next question. If the system of equations lambda x plus 3y equal to 0, x plus lambda minus 2 into y is equal to 0 has infinitely many solutions, then find the values of lambda. Answer. The system of equations has infinitely many solutions implies del is equal to 0, del 1 is equal to 0, del 2 is equal to 0. It is the concept. The system equation has infinite number of solutions, where del is equal to determinant of lambda 3, 1, lambda minus 2. Del 1 is equal to determinant of 0, 0, 3, lambda minus 2. Del 2 is equal to determinant of lambda 1, 0, 0. Since del is equal to 0 implies determinant of lambda 3, 1, lambda minus 2 is equal to 0, which implies lambda square minus 2 lambda minus 3 is equal to 0, which implies lambda square minus 3 lambda plus lambda minus 3 is equal to 0, which implies lambda lambda minus 3 plus 1 into lambda minus 3 is equal to 0, which implies this lambda minus 3 into lambda plus 1 is equal to 0, which implies this lambda minus 3 is equal to 0 or lambda plus 1 is equal to 0, implies this lambda is equal to 3 or lambda is equal to minus 1. Find the values of lambda. Therefore, the values of lambda three or minus 1. Clear? Clear? Okay. Note down. Next question. So that the determinant value is equal to 2 times of ABC into whole cube of A plus B plus C. Prove. LI side. Determinant of A plus B whole square, C square, C square, A square, B plus C whole square, A square, B square, square of C plus A. Apply C2 replaced by C2 minus C1 and C3 replaced by C3 minus C1. The given determinant will be A plus B whole square, A square, B square, C square minus square of A plus B, square of B plus C minus A square, 0, C square minus square of A plus B, 0, square of C plus A minus B square. Applying C2 replaced by C2 minus C1, C3 replaced by C3 minus C1. Taking common A plus B plus C from C2 and C3. Taking common from column 2 and column 3, which implies this, which is same as A plus B plus C whole square, determinant of square of A plus B, A square, B square, C minus A minus B, B plus C minus A, 0, C minus A minus B, 0, C plus A minus B. Clear? Apply. R1 replaced by R1 minus R2 minus R3 is equal to A plus B plus C whole square to AB R1 minus R2 minus R3. This minus this. This minus this minus this. Minus 2B. This minus this minus this. Minus 2A. A square B plus C minus A. 0 B square 0 C plus A minus B. 2 taking common 2 A plus B plus C whole square. Determinant of AB minus B minus A square B square B plus C minus A 0 B square 0 C plus A minus B. Apply. C2 replaced by C2 plus 1 by A C1 and C3 replaced by C3 plus 1 by B C1. So it gives 2 times of A plus B plus C whole square AB A square B square. It is 0 C2 plus 1 by A C1 that is 0 C3 replaces C3 plus 1 by B that is 0 C2 replace 1 by A that is B plus C. C2 B square by A. And C3 0 plus 1 by A square by B. C3 plus 1 by B, B cancel, that is equal to C plus A, which is equal to 2 times of A plus B plus C whole square into AB BC plus AB plus C square plus CA minus A square B square by AB, that is AB. AB cancel, which is equal to 2 times of A plus B plus C square, C taking common, that is ABC, A plus B plus C, which is equal to 2 times of ABC, A plus B plus C whole cube. which is equal to right hand side, hence proved. Clear?